Thanks. First, Bastian, for inviting and for setting up this Eurofriend webinar series now. I think in the third um, year already, which is really great. And all participants, thanks for joining. So yeah, the presentation is about to share a little bit our experience in terms of transfer from research projects into operations. So I'm the acting director of the International Center for Water Resource and Global Change, which is an UNESCO center. For that reasons, we work already worldwide with different activities related to UNESCO, related to WMO. And I think when you have followed this YouTube channel and other experience, it's not the first time that I represent. But I represent here also the German Federal Institute of Hydrology, and that is a German hydrological service. So that is more the, let's say, operational aspect of what we do. And then the question is, but I come to that later. Let's talk about technology readiness levels in hydrology. And here I would be really interested to learn also from your experience. So maybe the outline, short introduction to the topic. I have two examples with me. First, the International Soil Moisture Network, which is one of the global data centers which we do operate at our institute together with the Federal Institute of BFG. And then we do develop a global drought forecasting system, a seasonal drought forecasting system, which is already, let's say, from project beginning planned to become operational, or to at least to develop it so far that it can be transferred into operational mode. And the third thing is, let's talk about it, and this is more the discussion also with you. Let's talk about this terms of technology readiness levels. So, of course, there's a lot of literature. No, if you talk about research transfer, most of all universities, I guess, have kind of technology transfer offices. A lot of universities have spin-offs also going into the private business sector, and there's a lot of advantage. But I think we have always the cycle here that we have a kind of relevant product, research product, which is developed, and of course we also need the willingness to share this, no, and to bring that to operation. And then let's say a kind of circle which is described here starts working. If you look a little bit, and this is a slide my colleague Tin Wu has developed. If you look now a little bit on the time scale, so then it should be clear that the transfer pathway takes time. No, I mean, it's not foreseen that we start really with basic research and bring it to operation within only one funding phase of a research project, but we need several maybe, and we need several different partners as well to work on that. And also these pathways, they can also differ between various sectors. If I really want to make up a startup, a spin-off in the private sector, or will sell it to a company or whatever, or if the public sector and governments are using it. But for all, of course, you have to start somewhere, and this somewhere has to be described, I think, and might be better described, as it's sometimes the case, is our experience. And then we have to work on a concept also, and that's the second phase after the, let's say, initial project. We have to speak about collaboration, networking, co-design, marketing also a little bit to get interested parties in that might use the service and in an operation mode later. And here's a general time scale is 7 until 12 years. And this is, I had the discussion with Tin, for some aspects, this is quite fast. No, I mean, in operational hydrology, we have some really features which takes more than 12 years, maybe 2 decades or so is also quite often. No, I mean, also if you look in more hydrometry and how when to switch a complex monitoring system, for instance, it takes even some more time. No? So, but then we have this technology readiness levels. They were introduced. Doors ringing. They were introduced by NASA first, so by a space agency. and also for the aerospace industry, and were used to assess a degree of a development and a maturity level of a technical product. Those terms have been reused by research funders, including the EU, here with a Horizon 2020 program. So this annex was, I think, published in 2014, but still in the system and still kind of the basis. And I would also looking after the presentation who was already familiar with it and what does it mean. But in principle, all technology readiness levels look similar. They have different levels, in here 9 levels, and they start really from basic research. They, let's say, some blue sky research ideas maybe, until really a fully system which is proven in an operational environment and is really working there. So that is then the key what you aim for. So typically, most of the research funders end with a technology level of 4 or 5. And most of the, let's say, infrastructures and of government authorities or private sectors want to have something like technology readiness level of 7. So a system prototype has demonstrated already in our operational environment. And then there's, of course, a gap. No? And if you speak about, and then if you speak about other sectors, of course, aerospace industry is maybe not a fitting form. And now, in the course of time, there are already some adoptions of technology readiness levels also for other applications and sectors, which I will show you later. The motivation was, at least, we were funded by such a project from the German Research Ministry, and they said, okay, you guys, please develop something until technology readiness level of 7. Then we said, okay, but this is still a research project, isn't it? Yeah, actually, you should work with PhD students. So as always, PhD students have also other works. Instead of software development, they have to do science and research, they have to publish papers and so on. So there's also a gap. And then we started discussion, okay, what can we learn and where can we, until what we can develop something. And on this sketch, so please take the number series, that's the percentage on the x-axis. And you see some Grundlagenforschung, that's basic research. Sorry, didn't translate it, this one here. This is where you have a lot of doing research and then a little bit documentation maybe, and also, of course, data management is important. And then if you increase the technology readiness levels, of course, so the research part is getting smaller and smaller and smaller. And other purposes like documentation, like working on transferability, like on IT security, for instance, become more and more important. And as all of you or most of you, I'm pretty sure you have entered already this gap, and also this is difficult to get finance for this one. In my, I think, last Eurofriend presentation from last year, I already showed this slide here, but this is really good what we speak about. No? If you want to have a transfer or an operational product which is sustainable, we need a lot of requirements. No? There should be some automation because national services, for instance, they don't have the staff for doing manual work. It has to scale, it has to be portable, readable, traceable, a good documentation to all as meet the different facets, also open science, because this diagram was generated to discuss open science. No? But it's, I think that is one key and already one lessons learned today, that open science can pave the pathway to an operational use. So I come now to some examples. The first one is the ISMN, International Soil Moisture Network. As you may know, our center, together with the Federal Institute of Hydrology, provides services for 3 global data centers, mainly the global runoff data center for river discharge, which is operated by the Federal Institute of Hydrology, and then provided by our UNESCO center together with the Federal Institute of Hydrology, the GEMS Global Water Quality Data Center, and the International Soil Moisture Network. Since Wolfgang has introduced the ISMN, I think in October, I skipped too many aspects to that. So I can refer here to the last presentation also on the YouTube channel, but a little bit on the history. So the ISMN started and was established in 2009, and it really started as a student's project. It was funded by ESA, by the European Space Agency, to build up a database what the ESA needed for satellite soil moisture products for calibration and validation. Up to that point, there was no harmonized data set globally available. And the TU in Vienna, with Wolfgang Wagner and Wouter Torrigo, gets this tender, and they establish it, first starting with students. So they developed it, and quite fast it became the international soil moisture database for ground truthing data for in situ observations. And they become also part in the circle, which I do coordinate, the Global Terrestrial Network of Hydrology, which is a federation of different global data centers. The other three, in total, we are 11 or 12, ranging from global precipitation products, cryospheres in the three which I've mentioned, describing the water cycle, but also water quality, isotopes in water, and so on, are part in this network, which is funded, or which is, let's say, working under the auspices of the World Meteorological Organization and the Global Climate Observing System. And we have every 2 years meetings. And in 2017, the colleagues from TU Vienna said, okay, we have an issue. We are a university, we are running out of, the service becomes too operational for us. We are interested in research. We need an organization which can take over the International Soil Moisture Network. So we asked first the Austrian government, and they declined. Then we started to ask the German government and others, and Germany said then, yes. The story was a little bit fun. We had also maybe also lessons learned for operation of such big projects. We had a lot of luck because the minister for transport was in our house, and we could convince the minister on a personal, let's say, on a personal exchange. No, I mean, sometimes, of course, the hurdles within the ministries, if you only work via paper workflows and hierarchies, that it becomes difficult. So this was our luck, but I mean, I don't have to tell you, soil moisture becomes more and more important, and therefore I think it was also a clever move. Then we started in, and then you see 3 years between 2018 and 2021. This was really the formal time for the formal setup, getting finances for now 5 full finance permanent staff members, which we do have for the infrastructure and so on. So writing concepts, discussing people, writing concepts, how to implement, writing the transfer plan together with the colleagues from TU Vienna. And then we started the migration in January 2021. Also, this took quite a long time. You see it on the right-hand side. Financial clearance, you have the recruitment process, then the technical transfer and data transfer, also asking for the data rights, because data providers in all our data centers, we are not the data owners. No, we are only the custodians for data, and we have all to ask member states or the data providers if they agree. And then we got a legal clearance at the end of 2022, so next 2 years. And in 2023, we went into full production. It was in December 2023 that we fully took over. Important is here, we have 3 partners. We have the university really who is willing to give this baby child project away. No, I mean, that is also kind of emotional aspect. Second, you need a national authority in that case, partner with a functionality for long-term operations. And third, we need the politics in our case. No, and that is really because the funding comes from the government somehow, and you have to convince partners. And that is where we ended now. We have a contract between Vienna and ourselves, and our center and Federal Institute of Hydrology, written up about the transfer, and that is a system, how it looks like, and also what Wolfgang Corres has presented last month. So that is where we are right now, and we're really happy to serve the international community with this data center on operational use. And the data are also used, no? I mean, the impact is there. They also contribute more and more. Matthias Zink, the head of the International Soil Moisture Network at our center, he also have written now for this WMO State of the Global Water Resources reports the soil moisture chapter, so it's highly visible and also helps the data centers to get new data and to improve their service quality. And I think that is, if you have such a service, I mean, then you are in a certain infrastructure and the things becomes to roll. And but also it's really helpful to have also this, let's say, this high level support, which also WMO provides in that case here. No? So, and then the second project is Outlast. Outlast stands for an Operation Outlook for seasonal drought forecasting, multi-sectoral drought forecasting. It's funded by the German Ministry of Education and Research. And the aim is really to develop and implement an operational forecasting system. No, it doesn't mean that it has to be operated per se, because I mean the concept of what have you to provide a service that it's easy for them to take it over. That was one of the questions beyond looking on different sectors, looking how developing workflows, how it looks like. I go more into that detail. But for us, it was important to really bring in different sectors in one system. And also here, WMO was really helpful that they offered, okay, we're developing the global hydrological status and outlook system, which is done by the pilot is currently, or the development is worldwide, but the lead is here with the UK Center for Ecology and Hydrology in Wallingford in UK. And that's also great collaboration. And I think the idea was that we fill a gap in the system in a global perspective, which was not available in before. So that's with a lot of partners we have done this. As at WMO, Hydro SOS, UKCH, but also local partners in Central Asia in the Lake Victoria Commission, and then also our key partners doing the development from the University in Göttingen. They brought in the global crop water model. The University of Frankfurt, they brought in the water gap global hydrological model. The KIT is doing the bias correction of seasonal forecasts, and we do the integration. So what's about, as that maybe a little bit repeated, but we're looking for meteorology, agricultural, and hydrology for all different kind of droughts. We will provide a historical assessment of the last 12 months in operation mode. We provide the near real-time actual situation, so the actual status, and forecasts for the next month. That's a puzzle. No? And that's a puzzle, I mean, also related to technology readiness levels, if you like to do so, because we have different components, of course, and all the different components were developed by different partners with different ideas, backgrounds, features, suggestions, no, and also maybe also different time for increased maturity. How long are they already developed in the market? Do they have an open source developing community or not, or whatever for aspects comes in here? And that is also what we learned in this project. Maybe what is in back to Outlast, what is the idea to do? So we also developed some drought indicators for hydrological droughts, for meteorological droughts, and for agricultural droughts, for both rain-fed and irrigated agriculture. And I think in total we have 14 different drought hazard indicators used, reused, like SPI, of course, and other standard indicators, but also developed some new ones and discussed it with various stakeholder groups. So, and this is now going into the Hydro SOS portal, as I said, for different for different sectors. That was really important for us. And so from an operational point of view, it was really important to see what is needed for different users. So for end users and users, we provided this co-design aspect into the project. So we really asked, we developed something and asked if is it that what you need. If you use such a service, you all know that. But if you speak about co-design with a software developer, I mean, we know that because we most of our development projects and are working in a co-design framework somehow, I would say, in hydrology and metrology and our related scientific fields. But if you ask a software developer, for them is co-design something completely different. Now they speak then about agile development, about sprints, every 3 weeks something new, and so on. So that is really for them a different way of working, and that is also what we learned a little bit and tried what can we adopt and what is not possible to adopt. For the developer, it means in the project that we from scratch, from the beginning, we worked on the portability of the system. For us, it was clear. I mean, of course, our wish is if you start, in our case, as a national authority level kind of a project, the wish is, of course, that you can bring it to operation within your own house, within your own institution. But it was clear here we lack the commitment of the entire house, let's say, of the management board, of the ministry, because of course, if you have it on an operational level, then you have to discuss what does operational level mean? Is it 24/7? Are other parts enough and things like that? You have convinced people to have to negotiate, and there's of course always a portability, the issue that in your own house you cannot bring it to operation, but maybe others are interested, and that was also discussed or is also discussed and developed in this project to work on a system which is as transferable as possible. For operational services, always and really increasingly important is IT security. I don't know if how and on which level you discuss IT security when you start doing research. This comes more and more. We have now new EU framework directive targeting on that, and also research is part of that. So it might be becoming even more important for research as well in the future. And then we have, of course, concepts like continuous development, continuous integration on a operational workflow. So as said, I mean, also here the type of collaboration and maintaining and development is changing then. But maybe first, that was a summary for this. Coming back to the co-design approach, as said, the most important thing, and that is what most of the users sees, is a user-friendly interface. User experience is that term, and all that needs a lot of consultation processes, involvement, feedbacks, loop discussions. You need participation also. Let's say also from others, you have to bring them on board and keep them interested over time of a project. That is really important. And with each step which you see here, the time amount of that becomes more important. But if you compare different web portals, and I think all of you know web portals, and you see who has done a lot in user experience and which is not so easy to use. I mean, let's say for research speaking, I have my nice model, I have my Linux terminal and start on Bash some process. That is not really user friendly. And then we have really nice portals, also not overloaded, which shows maybe tailored to the end user, different views and so on. So there's a lot of to do. So that is again the puzzle, and as said, we have different technology readiness levels over all and everywhere, and that is what we also have to scale in this project. The aim is, as I said, here we have this a terminal, Linux terminal somehow, where we can do something with the model, but kind of view look similar in your environment, I guess. But on the right-hand side, you see the diagram how the entire Outlook service is yeah developed, let's say. No? We don't have to go into detail here, but you start at one point, you end at one point, and there are many different processes and which we worked on. No? And that is maybe our part or the part of Tenwu who's doing a great job to bring all that together and just discuss with different people where are we, what can we use already, what can we bring into one system. And one important thing is we work here with Docker containers. I mean, that is maybe probably new, but for us it's also a portable system, thing which is easy to deploy. And Docker containers turns out to be rather and comparatively easy to deploy because they bring a lot of references and requirements already within the Docker containers. So it's kind of a, yeah, let's say black box, which is then running in a Docker container, and we have to bring these different containers together. And then we provide a kind of cloud-ready system with this approach. Cloud-ready system also is, let's say, is a journey. No? The question is why to do it. Same again, if you're not cloud-ready, you have to do really a lot of manual work to scale, to start, and so on. If you improve and increase the level of bringing different services and different containers together, so that is the second part here. Maybe this is container ready. You have also some automated support systems like checking the liveness, doing some logging, managing IT security issues, and so on. Then the third is, again, even more factors are included. You can have external configuration, for instance, so you can from a computer run it on different systems. The deployment processes are really much more easy, and that is where we can speak then about kind of cloud infrastructure. And the full sector is that we have then everything included, scalability, IT security concepts, and telemetry, APIs, and so on and so on. And for the development, it's of course increasing level of effort to do. No? And for an operation level, it's also, you need more and more infrastructure. I mean, that is a level why you certainly, as a research project, if you develop your own model, you don't think about that you start somewhere here, and this is overhead which you don't think about. But you can already think about, okay, maybe that's the way I go. What do I need, which can easify the process for later steps? That is something what you might think already about. So as said, we built a Docker file, we constructed a Docker image, and certainly Docker containers, which can be run then on different systems. And then we also introduced an orchestration platform, which scales, let's say, also related to the system, which understands, okay, what resources are available, what is needed, and how when do I have to run which Docker container and bring it on a level. So this is not entirely something, I mean, maybe yes, because when we look on most of the models, of course, they are not on a Docker deployment way so far. Since we started now 2 years ago, I think a lot of have already worked on that, maybe you as well, would be really happy to having some exchange with you. But for the models which we have used here, that was certainly not the case. And then we come to one really also important thing, and that is IT security. This is really increasing. And again, already, if you do some research in development of kind of software, if it might model or might it some tools you develop, please have a look. That, I mean, when all of us use some kind of standard libraries, let's say, for doing some standard stuff. Please have a look and provide already for yourself a kind of workflow how you can easily update those. If you want to bring it on a national, on operational level, of course, then EU regulations or international regulations, international standards, national laws, and regulations comes in to play a certain role at the German Federal Institute of Hydrology. We are just not allowed to run services which have not been approved in an approved IT security concept or and the implementation, of course. And this has some implications for the research sector, which we found, because I mean, since we are doing both, the provision of guidance, our experience is nobody could give us really the guidance. I mean, there's some around which I will introduce on the next slide, but to understand it as a scientist, boy, no way. Things maybe as a next bullet point, development of templates and support of cyber resilience in the system, like software bill of materials, establishment of IT security concepts, vulnerability assessments. That were really also for us most of us, and let's say for the researchers, completely new terms. Never heard what software bill of materials is, or if there's a standard to do this vulnerability assessments. Also in ours, they are under development. It's also not the case that everything is already on that level, but we, of course, over the last couple of years, we improved a lot. I mean, there's a lot of also staff, new staff working on that, and this is really a challenging situation. How to do so. But there was also then questions if we now do the co-development. Think about a national authority. We are now working on kind of infrastructure. We found a way that we used, let's say, a safe space where we can do the co-development, but it's of course not possible to just work on the critical, let's say, internal infrastructures where our operational services are running. No? But on the other hand, it's also kind of trust who's working with whom on which system. I mean, that has really to clarify it all in before. And then we have some guidance and some also for EU now speaking some directives. One is a new network and information security directive, which became active in 2022, and the member states had time until October this year to implement that with national laws, which has been done. There has been kind of a lot of sectors already involved, like energy, drinking water, banking, and others. But also now there are new sectors. No? Public administration is in, research is in, telecommunication and IT services in. So all what we, let's say, do with our also global data centers are kind of part of that. So that is really, of course, needs some more efforts and resources for us. And then there are some also guidelines which you can use for getting kind of basic projections. That is now what we use here in Germany. I think most of your countries will provide something or have to provide something similar. Otherwise, those are helpful. But again, I mean, this is a really complex systems with a lot of also self referring documents somehow. So it's really jungle, and without guidance, it's really difficult. But on the other hand, we were really sure, and we already wrote in the proposals based on our projects, which we worked further including the transfers of the International Soil Moisture Network, which was one of the first projects where we had to write such IT security concept for the entire Federal Institute of Hydrology. Based on that experience, we started, and we said, okay, we start even with this German basis information implementation documents somehow, because they are kind of transferable, of course. I mean, it's IT security, even if there's no international standardized document format, the concepts are also via this National Information Network and Information Security Directive kind of harmonized, of course, and we have ISO norms and others. So that should be transferable, but you have to start with it, and you have to really think about it. So this is close to the finalization with this project. and we had also some hope, so some luck to get some support from external tender to help us in this situation. But this was also some luck. Otherwise, it's really also time consuming. Yeah, and that is how, the hydro how it looks now. I mean, you can have access via the website from CH, who provides a WMO hydro SOS service. So if you're interested in that, please have a look on the sport lowers there. And then, oh, that's bad quality figure. Sorry for this. Maybe what have we learned, and how can you use it? Again, I mean, this is the red point is a typical level of resources which you have in such part of a project starting from scratch, let's say, to operations. So also related to technology readiness levels. If we start basic research project, I mean, the funding is high. You get a PhD, you get 1, 2, 3 PhDs, whatever, you can work on that. Maybe you even get a subsequent. Then we are here somehow, and maybe you get a subsequent contract. I mean, but that's maybe only one position, half position, but it's really reducing, no? And then we have here in this gap, which I've said, from basic research to applied research, and then is this technology development, and nobody really feels responsible here. And that is, I mean, that is for all of us quite known. And we really have to think how to bridge this gap. If you have crossed leveled a certain aspect, then it becomes more easy, because then, as said, here with a technology readiness level of 7 or so, it's rather easy for others to take over. No? That is the aim, and to reach it. Here's a little bit literature which we found in this process. Here for the Horizon Europe, there's a portal for the national focal points, national contact points, which helped, and they translated the technology readiness levels also to different sectors, let's say. Here, the link is there, and here you find a solution for software development. No, so and also with some examples which might be really helpful. And so looking at what we speak now about, maybe if you're unsure if it's now technology readiness level 5, 6, or 7. So that's the alpha version, technology readiness levels 5, which also Outsiders has used. Then you develop a technology readiness level to a beta version, which is quite advanced already. And you use it with selected end users under a control mode. And then the beta version is something which we already show to wider community of end users. And that is what in the Outlast project we will try to reach, because one aspect is here that we are working via this Hydro SOS portal, and therefore it's per se intended to use a wide user community. On the other hand, you have to assess it for all different aspects on what level you are. And as I said, we have this puzzle of different components, and it might also be the case that the internal compartments reach different kinds of technology readiness levels. I mean, that is what you have to consider, and also to work on it. So here's some more information from the EU space in terms of funding. So we have the research and innovative actions, and also here I think the slides will be provided on YouTube. You'll find it later. That is what kind of technology readiness levels such kind of activities tend to implement. No, I mean, for this research innovation actions, you start quite with basic research, maybe a little bit more advanced, and reach something really in this operation gap. The innovative actions that cover maybe this gap already. So if you already have a project which is interesting for that, calls from this action might be more interesting than from the research and innovative action. So please have a look on what's going on. On the other hand, we have also the blue sky research, the typical ERC concepts. And that is kind of the basics, the fundamental research part, starting from scratch and develop something to a technology readiness level of 3 or 4. And then we have the innovative council instruments also for 3 different classes. It's the same again here. Please have a look what you're interested, what is your project outcome, and what is maybe the level what you want to reach and your partners, and select the fitting call. And now I make a big step back. Most of this is also, I mean, not entirely new, of course. No, I mean, but the consequence was that not long ago, in 2021, the UNESCO wrote the recommendations for open sciences. And it was really adopted by all 100 or most of the 193 countries attending the conference. And all that aspects are in here, like using open licenses, sharing publications, data, software, and yeah, even hardware might be the case. And based on that, and I think Nila is also here, she's co-author of this famous publication here, the Hydrology Guide to Open Sciences, and also that worked, of course, on that concept. And when in my last presentation here, I focused more on open data collections. Now I focus more on open code. So if you develop already and train your own skills in this co-development, software co-development using GitLab, GitHub, and other tools, bring it open, understand what the different concepts are. I think that is also key and really simplifies the process for later operationalization. I mean, if you are now more coming to or are a younger early career researcher, that is speaking that off, you on a good time then probably, you know. Yeah, and with that, I would like to end on the right-hand side, one picture from WMO, because in WMO we have in hydrology of 8 ambitions, long-term ambitions, and ambition number 5 is that science is a sound basis for operational hydrology. I think that was a talk here about today. It's for data management, it's for products and for services, and how to develop those. And yeah, one should have in mind, if one really should look for operationalization, this required really change in the attitude and in the consequence how I do develop, with whom I do it, who are partners, who can bring it on one level. So that is really important here. Technology readiness levels helps you to have an assessment where you are and in which direction you want to develop. However, they are not so easy to understand somehow. It's not so easy if you bring different sectors together, because they have kind of all different interpretations, let's say, of this, let's say, 9 core principle. Again, they were developed by a space agency to build a rocket or whatever, or a satellite, so completely something different, comparable if you want to provide or bring a hydrological model into operation or whatever. And it would be good if you use kind of standardized checking systems which are available. Here in the documentation, I wrote something from ESA, but I would rather go now. I have to update this. Sorry, I have to update this topic with the information provided to the national focal points of Horizon projects, which are better equipped. Again, ESA, also space agency like NASA, it's sometimes not really fitting. Also, they have developed such kind of assessment tools. And the last point is taking also IT security into account if you want to bring it on a perspective. No, it's then when you start with then it's helpful to have a look on national or international standards. What is really meant with that? What boxes I have to have to mark on it, assess your own system. What can I provide, and what has to be developed before an operational service authority or whoever, also from the private sector, can take over. I think that is important. And if you have already a business partner there, I mean, it's of course helpful then directly going into contact and to learn how the new aimed infrastructure looks like. No? Then you can also from a, let's say, more generic analysis and implementation, you bring it into a tailored system. And yeah, but expect that this also takes a lot of time. And with that was my final slides. I think also Tin and from the Outlast project, who has provided a lot of slides, and also Matthias Ching from the International Soil Moisture Network, and all the team members I do have. And yeah, happy for questions and discussions if you use technology readiness levels or not.